Welcome to another riveting addition to linear relationships. We are looking at the very last section of this unit called comparing linear relationships. So we're going to look at tables and graphs and equations. Oh my. We're going to be looking at the slopes and comparing those most specifically. So I've got two runners that are completing a race, runner 1 and runner 2. Runner 2 is the easiest to decipher. I can tell by looking at the equation and zoning in on the slope or that rate of change that runner 2 is traveling 9.5 minutes in 1 mile. Runner 1, we have to actually calculate the slope to be able to figure that out. So we can pick any two coordinates. So I'm going to pick the first two. I'm going to pick 2, 18.5, 4, 37, and I'm going to use my formula. I'm going to kind of scooch up here a little bit so I can use some workspace. So y2 minus y1 over x2 minus x1. All right, so I like to label these. So this is x1, y1, x2, y2. So that's going to be 37 minus 18.5 divided by 4 minus 2. 37 minus 18.5 is 18.5. 4 minus 2 is 2, and that's going to give us 9.25. So runner 1 is actually traveling at 9.25 minutes per mile. Okay, so who's traveling at a greater speed? Well, who's going to get to the finish line faster? The one that's only taking 9.25 minutes a mile, or the one that's taking 9.5 minutes per mile? Hopefully you guessed runner 1 is quicker. Okay, so and the reason why is because runner 1 is traveling, or running, I guess I should say, at 9.25 miles per hour. Runner 2 is running at 9.5 or 1 mile and 9.5 minutes. Okay, so I said miles per hour up here. Obviously, it's not going miles per hour. That would be 9.25 minutes per mile. Okay, just to clarify. All right, we have the Smith family and the Johnson family, and they are both driving on family vacations for winter break. We need to find out which one is traveling at a greater speed. Well, the Smith family looks like our equation is y equals 58x, where x is the number of hours and y would be the number of miles. So they are traveling at 58 miles per hour. Okay, and the Johnson family, we have a graph, so we have to find the rate of change from the graph. So I'm going to pick any 2 points that are on the line that meets an intersection. We have lots to choose from. Any of these points will work, including the origin. I didn't pick that one, but you get the idea. I'm going to just pick these two right here. 2, 100, and what is that, 4, 200. Alright, so I can see that my y-axis is increasing by 50, so that's 50, 100. Okay, over here this is increasing by 1, so this is 1, 2. My rise over run, divide that out, get my per unit rate, and the Johnson family is traveling at 50 miles per hour. So I'm going to compare the Smith family at 58 miles per hour, the Johnson family at 50. Who's traveling faster? The Smiths. Okay, the Smiths are traveling 58 miles per minute. 58 miles per hour. I'm sorry, it's late. And the Johnsons are only traveling 150 miles per hour. Okay. Go ahead and finish writing that. Meet me on the next problem. Okay. And the next problem is all about Bennett and Jarrett. They're both saving money to buy dirt bikes. One thing jumps out at me right away, and that's that Bennett is already starting out with $115 in his account. Jarrett is starting out with $0 in his account. But the question is not asking who has the most money. The question is saying who is saving money at a greater rate. So we have to find the rate for Bennett. We have a table, so again, the best way would be to pick 2 points out of the table. So I'm going to pick 0, 115, 1, 163, and we'll apply our slope formula. Again, x1, y1, x2, y2. So 163 minus 115 divided by 1 minus 0, and 163 minus 115 I believe is 48, and 1 minus 0 is 1, so that's going to be $48 a week that Bennett is saving. Now with Jarrett, got to pick some points on that graph and apply our rise over run. Okay, so I'm actually going to use the first two. I'm going to go up from 0, 0 to 1, 50. So we have gone up 25.50 and over 1. So rise over run. This is showing that Jarrett is saving $50 per week. So who's saving money at a greater rate? I sure hope you said Jarrett is. Now notice the question didn't say who has more money. The question says who is saving at a greater rate, and Jarrett is. Jarrett is saving $50 a week. And Bennett, that's my little and sign, is only saving $48 per week. Okay, hopefully you're getting the hang of that. The next one we have Lauren and Sean. They are skydiving. Okay, Lauren's elevation is expressed as an equation, y equals 13,000 minus 172x, where x is the number of seconds and y is the elevation. So it looks like she's starting at 13,000 feet and she is descending at 172 seconds, 172 feet per second. Okay, Sean looks like he's starting at 12,500 feet, and we have to find out what his rate of descension is. So I'm going to pick again any two coordinates from the table, label them, okay, and apply my formula. So I'm going to use some workspace under Lauren's elevation. So here's my formula, y2 minus y1 over x2 minus x1. Okay, y2 is 12,150 minus y1, which is 12,500. Okay, on the bottom, 2 minus 0. All right, so 12,150 minus 12,500 is going to give us a negative 350. On the bottom, 2 minus 0 is 2. Okay, so when I divide that out, Sean's elevation is a negative 175. What is that going to be? Feet per second. Okay, so Sean is decreasing at 175 feet per second. Lauren is decreasing at 172 feet per second. Who is descending at a greater rate, Sean or Lauren? Well, Sean's getting to the ground quicker, so Sean is the one who is decreasing at a faster rate. Okay, so Sean is descending. I had to think about how to spell that. At 175 feet per second. Lauren is descending at 172 feet per second. Okay. And that's pretty much it. I don't know if that was a relatively easy lesson for you or a little bit difficult. If you had any questions, find Mrs. Bird or myself and we'll be happy to help you out. Have a good evening. And that was my dog Penny. She was telling you good night as well. Actually, she's trying to chase my cat around the house. All right, guys, have a good night.